everyone. Welcome to the last session for today's track of quality gems, and we're ending with a real gem indeed. The talk is about shift right into the metaverse with digital twin testing. And there's a lot to say about our speaker. I will not say anything, I'll just give you Jonathon Wright.
Hi guys, hopefully you can hear me okay. Let me share my screen. Looking forward to closing off today's closing keynote. I'm speaking all the way from KubeCon in Detroit. So I'm at the event today, which has got over 7,000 people attending from around the world, talking about really next generation. So what we're talking about as far as moving to the cloud, modern day development techniques. And I'm actually in just around the corner, we'll be presenting around Metaverse and what that means to test and how you guys can get involved with testing this next generation technology. So a little bit about myself. I've been doing test automation for the last 25 years. I'm referred to as the automation cyborg. I'm just going to get my HoloLens for a second and just to give you an idea of what you're kind of seeing there in the background is my presentation, which I did at TED. It was about 6 years ago. And actually I was presenting what happens when you use this technology. So this is actually a HoloLens, which I have Microsoft just over there on the left-hand side, who are also at this event. And what you see behind me is an augmented reality viewpoint of mixed reality. So obviously I can see the depth in front of me, very much like the Oculus Pros, which are getting released by Meta tomorrow. But also I can interact with the real world. So I wanted to kind of give you a bit of background about myself. Like I said, I'm here at KubeCon this year, and Keysight are sponsoring the event. They're a platinum sponsor. Actually, if you see down on list there, you can actually see when I was speaking back at CES when we launched our first radar emulator. So hopefully that gives you a bit of an idea of what's going on, what I'm doing at the moment. And then what I'm going to do is I'm going to kind of go into some of the content for today. So I was actually speaking at an event a couple of weeks ago, Star West, out in California. And I was kind of talking about this kind of move to how do we go through this journey, should we say, for a second, of testing and test automation. And actually what I'm going to do is I'm going to broadcast now that I've changed my input, so you can actually see what I'm seeing today as a bit of a preview. Okay, so hopefully this will give you an idea. And so for those who are not familiar with Keysight, Keysight started as the original Hewlett and Packards back in 1938. And, part of it was they started building test equipment back in that date. And that was a real challenge. Of course, the first ever unit which was provided was for Disney. So again, for some of you who are not familiar with Keysight, I thought I'd give you a bit of a glimpse. I'm just going to swap back and restream, and hopefully somebody in the back who's banging around won't be banging around while I'm doing my live stream for much longer. So hopefully it gives you a bit of an idea of what Keysight does and how we actually, how we've evolved since the early 1900s, back as the kind of creators of Silicon Valley, shall we say, for a second. So where are we today? Well, there's a long journey that's gone from the days of, when Hewlett and Packard set up the original first test equipment, the 200D, back in 1939. But also I'm talking about artificial intelligence. So part of it is, if you look behind me, just down the road from where I live, a place called Bletchley Park, is where Alan Turing wrote the original documentations on artificial intelligence. It also, he published around the singularity and how we're looking at evolving to this level. So I wanted to share a bit of that context and then kind of bring you up to date with where we are today, how we're evolving with the next generation of test equipment, and how we can help you on that journey to potentially leverage some of that technology and actually start testing highly complex systems, to give you kind of that context. So why testing and test automation, which is why we're here today at TestCon, is really about the acquisition of Eggplant back in 2020. So this was Keysight's first step into kind of software test automation and really becoming a software company as well as a world-renowned hardware company. And like I said, when they made that first equipment, which you can see there on the left-hand side, that was actually delivered to Walt Disney, and actually Walt Disney used it for the creation of the first ever stereo sound in Fantasia. So, this is in our DNA, but also we've been testing since 1939, and we're testing the technology that's going to come through today and tomorrow. So what you see here is not, I'm going to be talking a little bit later about Ada Lovelace, which is our autonomous design automation capabilities. And this is a nod to Ada Lovelace, who was the first ever computer programmer back in 1815. And not many people know, but she just lived a few miles away from one of our R&D centers in the UK. And what you see is Satish, who's our CEO, coming to visit to talk about the metaverse and how it's so important for the next generation of technology. So a little bit about Keysight, a bit of an introduction to give you an idea of, we're now the largest pure play testing company on the planet. And, to give you a bit of a context of just our breadth and of our organization and our reach within the kind of global footprint. So let's get on to shifting right into the metaverse. So why is the metaverse so important? Well, first of all, Gartner have just announced the metaverse as the highest item on the Gartner hype curve. Yes, there's a 7-year runway, but within that 7-year runway, it's at the absolute peak. So it's really quite exciting that we've got this great opportunity, which is a 250 billion to 400 billion pound marketplace by 2025. And I'm actually at the Gartner in Barcelona a couple of weeks from now, speaking there around this kind of technology. But for some of you, you might be also interested about some of the other areas, such as automation and about the application of artificial intelligence within AI to allow us to reduce 50% of our everyday workload and look at automating and using artificial intelligence. Additionally, I'm going to touch on at the end some of the quantum use cases that we've been doing with Azure Quantum and how they may be relevant for you and how you potentially the industry is going to move forwards. So last week I did a session for Keysight World. So if you go to keysight.com, there's a 4-day completely free conference. We talk about 5G and 6G, which I'm going to be showing you today. Day 2, we talk about quantum computing, which I'm going to touch on briefly. The 3rd day, actually, I'm involved with the digital twins and artificial intelligence track, which I would recommend checking out. And then finally, there's the autonomous vehicle testing, which I mentioned back at CES earlier in this year. So as you can see, there's a bit of a viewpoint of those ones. They've got all global thought leaders. I did a fantastic session with Dr. Poppy Crum from Stanford University, who's a neuroscientist lecturer, and we talked about some of the use cases of digital twins and artificial intelligence. So let's talk about it, give a bit more context around, well, how do we add artificial intelligence and machine learning to kind of automated tasks that you're doing today? What's the value of doing that? And how do you get started on this journey? So within our DNA, we the number one vendor in both the Gartner and Forrester quadrant. And actually, a few weeks ago, I was with Diego talking about this year's Forrester Wave and showcasing some of the technology which you're going to get to see today, which is next generation predictive analytics. It's artificial intelligence. It's the taking all of this technology and leveraging it to provide you intelligent automation. Okay, so let's go on the bit of a journey. And I'm going to start off with kind of some of the foundational components of how do we potentially solve some of the problems that you guys in the audience today are actually talking about? And how can we help you automate those complex environments? I mentioned I'm going to do things like the metaverse, but also, some of these other areas such as cyber systems and robotics. And I also mentioned about quantum computing. So we know there's challenges. We know there's challenges in the industry around leveraging this kind of technology, around keeping up with the cost and speed, quality, and also more importantly today is around true E2E testing. So testing of very complex systems across the entire landscape. And this is there so we can deliver these amazing experiences on incredibly complex systems like we've shown on the stage, which could be things from NASA. So we actually launched the rover into space a few weeks ago, which was actually tested with the Eggplant software, but also some of this other technology like Car2X, Infrastructure 2X, which I'll also be showing you today. So digital twins. What is a digital twin? And it's quite easy to kind of say, digital twins are in essence a digital representation of a physical system. However, what does that mean when it comes to software testing? Well, within software testing, we've used things like model-based testing, and model-based testing has been there for quite a long time. And actually, we sit on the committee for the ISO 29119 Part 8 for model-based testing, and Eggplant are at the forefront of model-based testing within the entire industry. So part of it is we're taking this technology, which we've been evolving for the last 15 years, and we're leveraging that towards a digital twin. And what we're then doing is bringing this kind of ability to test absolutely anything. And of course, in the bottom right-hand corner, you can probably see their mega cloud deployments. I've mentioned that as a kind of a nod to the fact that I'm here at KubeCon this year, and the ability to test, I don't know, K8 deployments, Azure, Google Cloud, and AWS, wherever your systems are, even if they're an IoT endpoint in a car or an IVI system, we can test that system. It's not just a UI and it's not just an API. It can be anything. It can be hardware, it can be software. It can blur the boundaries between hardware and software. So with that said, I'm going to kind of give you a bit of a viewpoint onto how are we testing mixed reality. And if I panned over to the left, just to the side of me at the moment, we've got Microsoft here today at KubeCon. And, we'll be speaking and hopefully live streaming with the guys there a little bit later on. But, we've been working with people like Microsoft with their HoloLens 2.0 technology, as well as the Meta with their Oculus Pro and Oculus 2 kind of consumer devices. And of course, we all know that we're looking at Apple and to release their kind of mixed reality devices with this kind of technology, probably within 2024 to 2025. And also Google to bring the second device. So if you remember the Google glasses for the first generation, which used a QR code to scan and get the information in the real world, they're looking at bringing up their next available thing. And yes, someone pinged me on my my Ultra iWatch. These slides will be available to you to be able to check out afterwards. So let's talk about mixed reality. So mixed reality, as you can see right at the moment, is not virtual reality. Virtual reality is putting yourself into a virtual environment. This is overlaying into the real world. And when we say overlaying into the real world, I'm able to interact with anyone and anything that's around with me. Of course, there's use cases in healthcare and of course military. And then there's also use cases for, the first twins that were separated by surgery using this kind of technology. So how do we test this? Because it's a completely different type of device. And what you see on the left-hand side is all of the different technologies that we have as part of the Keysight heritage capability. So we can put these devices like the HoloLens, which I'm wearing at the moment, into an environmental chamber, which you can see in the bottom right-hand corner of this picture. We can then add in things like temperature control with the temperature devices. We can then potentially, on top of that, actually use things like our UXM technology. So that's our protocol emulation. So we can emulate both the physical layer, as you can see there. you can see the next level above is our protocol emulation capabilities and physical interactions. So we got things like 6 direction.
Jonathon, do you hear us? We lost you. Hello? We don't hear you. It could be Pine.
Okay, so hopefully,
Hi.
can you hear me now?
Yes. Hello. Hello. I can hear you.
Perfect. Sorry, unfortunately, my wireless mic decided that the battery was going to run out, which is actually a great example for this discussion around hardware and software. Because in a few slides' time, you're actually going to see us running a mobile device where we're actually looking at the battery drain. So, of course, this software and this broadcast today, all the way through from Detroit, is relying on all these different areas, audio streams. I've got a Sony VXF, which only released a couple of days ago, live streaming the camera. There's all of these different components. But anyway, picking up from where I had left off, I was trying to access the internet. I docked a very simple web page. And then within that web page, I connected to the internet. And then I was able to actually start overlaying stuff into the real world. So that could be just a physical 3D object. Sorry, my HoloLens keeps on popping back up. And it understands the landscape. So it understands from the LiDAR perspective, it understands the radar, it understands the depth. So part of it is it can overlay objects into that real world. And not only once it's overlaid those components, but I can actually interact with those components. So in this particular case, I was waiting on the plane to take off. And the next thing was I thought, oh, well, I'll go and have a look. And look at what the real-time air traffic control was around the airport I did. So I quickly switched applications. I was then able to look at where I was. I was able to then interact with what the planes that were coming in. Now, of course, I'm not an air traffic controller, so this information was no use to me, but it gives you a bit of an idea of the application about the ability to interact with these things wherever you are, whether you're on a plane or within the physical world itself. So, like I said, part one is being able to drive the hardware, drive the software, drive all the device inputs and outputs. But the next thing is both the Apple devices, the Apple Glasses, the Google Glasses V2, and also the HoloLens 2.0, and now the Oculus Pro, what gets released in tomorrow, all require eye tracking. So eye tracking is where I'm looking straight at the camera now. Actually, I can look to the right-hand side and I can use that to focus on where the menus are. I'm also, from a rendering perspective, it's only rendering the items that I'm looking at and focusing the processing power there instead of trying to render everything. And again, like my wireless transmitter, runs out of battery very quickly. So what you see on the left-hand side is us using OpenCV to allow us to capture the eye movement. And on the right-hand side, you can see one of my guys in our Cambridge R&D labs who's actually then replaying those eye movements on 2 LED screens which we feed into the actual device. And on the top, you can obviously see the body tracking. I mentioned things like this, where I'm getting the gesture control. I'm also able to understand gestures and overlay that from a body and how the skeletal system actually interacts and works. The next thing I kind of said, and I'm going to kind of give you an idea of how we actually bring all this together and make it work, is, it's fine being able to, in essence, move and drive it around. So like my head's just moving all the way around. Now, obviously I can't do that. I'm not from Poltergeist or whatever the movie is. So, part of it is you have to be able to input realistic inputs. Secondly, you need to be able to see what's happening in the 3D world. Now, the 3D world is actually wrapping around my eyes. So it's actually not a static image like we're used to on a browser or any kind of mobile app. So we need to be able to use computer vision to actually recognize objects in the world. That could be text, that could be a tree that sits in the background. So we can use computer vision to recognize objects. And then once we've recognized the location of those objects, we're able to then move the 6-directional input to actually go and interact with that. So instead of me having to point in front of me and click on something, which is what I'm doing at the moment, I can actually send those same commands, those same locational information, and drive the interface. So I'm going to show you how this works with a digital twin on the left-hand side, with in the bottom right-hand side, where we're moving the controller slightly to the left, slightly up, to be able to then click and interact with a browser. The next thing, what we're trying to do after that, is we're going to show you how, once we've actually interacted with this technology, and hopefully, how we're actually then able to actually drive it from, get all the information. So what you're seeing from the camera eye on the left-hand side, and also the telemetry information on the right-hand side. So information such as, the GPU, the battery, which was obviously fairly critical for the microphone issue that we had in the live world, but also the radar. So of course, the big change with the Oculus Pro is that it's a mixed reality device. Thus, it actually is able to see through in color instead of just stereo kind of black and white. So we're seeing this image in the 3-dimensional landscape. In this case, you can see a bit like the gecko that I put on earlier. You can see, oh, thanks, Joe, for your like on Twitter. But Joe Colantonio always refers to me as the automation cyborg, sent back in time to help save the world from bad software. So I have my 3-dimensional object, which I'm putting into the current state. Well, why is it the dog not fully rendered? Now, of course, people like the US Army are using this in environments at the moment, and they're, having motion sickness, which was reported quite recently. So how do I make sure, the image is correct, it's rendering correctly, it's the location is correct on the screen? And then also, what is it? Is it noise? Is it, because I'm on the battlefield, I don't have, internet? Is it satellite? Is it, direct access to the signal? Is it protocol errors that are dropping? Equally, once I see that object, which I know is a 3-dimensional component, how do I make sure I don't, I can actually interact with it and see it and then do something with it, whether it be, actually interact with it or something else. So the next bit is I wanted to kind of just give a bit of context. So like I said, I was at Star West a couple of weeks ago. And at Star West, I was chatting to my friends Dynatrace, who are actually at the event today, just on the other side of the area, and so Dynatrace was showing this great example around open telemetry, which is what we use at the moment for creating our digital twins, and how we can take open testing and open telemetry and open tracing and bring that information in. But what you can see is they've got 2 people using this HoloLens technology, and this is actually a demo from about 4 years ago, where they're actually coordinating and actually working on the pure path, and then looking at the exhaust data and in the information that's coming out, and actually be able to analyze it together. So from a test observability, they're able to look at what the root cause analysis, the pinpoint failure analysis is, and then actually be able to, potentially solve or resolve that issue in near real time in global locations. So incredibly, useful in kind of example of a real world combination. The second thing, I mentioned at the start was about the fact that we're also doing things like Car2X, infrastructure 2X, and vehicle 2X. And what you can see in the bottom of the demo here is we've got 2 Car2X devices which you can physically put into cars. And and they will send information of where those two cars are. Now, back at CES in January, we launched the first ever autonomous vehicle radar emulator, which is what's under the cover to the left-hand side of the video playing. But actually, just being able to create 500 up to 512 objects on the radar interface is only half of the solution. You actually need to be able to, if I'm an autonomous vehicle like a Tesla, I'm driving down a road, if there's a car that's coming around a corner and there's a blocked building in the way, of course I can't see that device. Whereas if I'm using Car2X, I'm actually able to see that device is maybe going too fast, it's not slowing down for the junction, and I can start braking without actually any of the autonomous capability detecting the radar in front of me. So as you see in the background there, the radar with all the different cars that are there, we're also doing that from a infrastructure to X as well. So you could, in theory, turn up at a traffic light system and actually keep your foot flat on the accelerator, and it would only be when the light turns green that you would actually be able to start and your car would start driving. So I mentioned earlier on as the kind of the classic battery issue that we had earlier. Here's an example of a product which we have called Nemo, which is actually in the bottom right-hand side of here. So this device here is actually a battery analyzer. So you can see how much battery drain is going on that device. And then within that device, you can also see the waveform analyzer, which is giving you, and the spectral analyzer, which is telling you that it's downloading some information from speed test, or it's sending information for a call that you're trying to make, or you're trying to use YouTube or something else. So incredibly powerful to bring all of the solutions and hardware and software together to potentially allow you to test absolutely everything from an IoT device onwards. So I mentioned kind of cell, and obviously I'm reliant at the moment on network, but how do we deal with network and also things like 5 and 6G? So I know from keep on traveling all the time that if I try to make a Teams call and I'm going between two separate cell towers, that I will get packet loss, I'll get errors, I'll lose connection, I'll have to reconnect to Teams. And as you can see from the demo that's actually playing at the moment, you can see that actually we're actually creating and injecting errors into the message, so that when you do the phone call, then you actually get those drop calls, and you can understand, well, how do I hand over to the next cell stably so that we can actually do these calls, we can establish continuous connectivity. And then there's the infinite question about, well, what's the difference? And this is the big play for for next year, and I think we're going to be talking a lot more about this, which is lifecycle virtualization. So bringing network function virtualization, which is what you see below, which is actually replicating the difference between a cell tower maybe using 5, 6G versus a Wi-Fi on maybe Wi-Fi 6E, and then actually be able to run A/B testing against each one, look at the difference between the amount of battery drain. Of course, there's more battery drain using your 5G connector than there is using your Wi-Fi 6 because it's a lower amount of battery pull. So part of it is you can use things like network virtualization, network function virtualization, and service virtualization combined with application virtualization to actually allow you to test all of these complex systems, from games to apps in the metaverse. So once you've been able to do that, you need all the telemetry information to be able to understand, well, what's the difference? What's the performance increase? What's the drain on the system? And bring all of that data into your testing. The next step is around, I mentioned cyber physical systems. So how do we deal with something which maybe needs near field to start off with? It maybe needs your chip and pin kind of thing, where you need a robotic to be able to actually interact with the physical world. And that's one of the big things when we're talking about the metaverse. It's the ability to interact and blur the boundaries between the real world and technology. So within this demo, you can really see the true capability of true E2E testing. Is I'm testing across a number of different systems, different iPads, EPOS systems, and what you'll see even at the end is a receipt popping up with a barcode, and then we're correlating that barcode back with that QR code and going back and checking the backend system took the right payment for the right front-end system, and bringing all of that information together. So testing all of the things and providing that level of confidence that not only one system tested in isolation is going to work, but beyond system integration testing. Also, of course, when we talk about things like the 6-directional robotic systems that we have, the ability for us to actually interact with physical things, which could be a lot bigger and require a lot more repetitive requirements. This is one of our devices, which is actually using our Keysight RPA tool to actually drive and interact with the system and repeatedly interact with that thousands, millions, hundreds of millions of times. Now, of course, you probably watched the Elon Musk's announcement around being able to do robotics testing and actually have maybe a cyber robotic system test as a tester. But taking all of these feeds and be able to test in the real world, this isn't that far away. You know, the idea of having one of these for $20,000, being able to interact and test with systems isn't so far away. So autonomous vehicles, cyber robotic systems, you know, really we're just on the or the cusp of this next generation of kind of capabilities. If we then move to kind of, well, how do we potentially leverage these digital twins and autonomously generate your testing? Actually, I know I've only got 14 minutes left, but I want to just quickly kind of go into some of the stuff that I did for a book at the start of the year with Rex Black on artificial intelligence for software testing. And actually, I did a great case study with the guys at Eggplant around helping saving lives during COVID. And it was all about Shift Right and how we leverage that technology to actually help us test today. So I wanted to kind of give you a bit of a practical understanding of, well, what is a digital twin? Now, you probably can see on the left-hand side, Bruce Willis. Now, unfortunately, Bruce had some bad news recently, and he's got a terminal illness. So he's actually given over the rights through the Acting Guild to actually allow him to continue acting as a digital twin and actually overlay him onto a traditional actor and actually interact and maybe play in the next Die Hard movie. So this ability to use maybe what we would normally look at deep fake technology and think that, what's the chances of creating myself a digital twin of myself? You can see the applications of this and how potentially it can be leveraged today with the technology that we have. So if that's a digital twin of Bruce Willis, then what's a digital twin of your system? Now I'm going to take the example, we could have gone into, I mentioned NASA earlier, we talked about the military use cases and cyber robotic systems, but I'm just going to take a very simple application or an application under test. How do I test that system and create a model within minutes to give me all of my tests autonomously? So what you're seeing here is the ability to observe a system, create and record all of the paths that go through that system, and then actually be able to rerun that. So how do we do this? So first of all, I wanted to talk a little bit, I mentioned at the start about Ada Lovelace and the ability of using the autonomous design automation. This is something that we're working on at the moment with a number of different companies. And of course, another reference to Back to the Future there, but the flux capacitor, it's about being able to capture not just UI automation, but take some of this open telemetry, like the guys here today, Splunk and my good friend Todd DiCaprio, and Dynatrace and Andreas, take their information to enrich the models that we're doing, use our own product, which we have, which is Real Customer Insights, use log analytics, but also use things like spiders to transform and interact with the application autonomously. The next part of it is once we interact with the system, and in this example, I'm going to talk about Keysight.com, and I actually here at an event at Swiss Testing Days, a few months ago, I actually live on stage said to the guys in the audience, I said, everyone go to Keysight.com, go and do some weird journeys, change some languages. Obviously it's Switzerland, so they're multilingual. And then I'll come back later on and show those exact journeys that people in the audience have done, plus real users that were accessing the website. And then I'll take that and what we refer to as hyper baselining, and then actually create a model. So what you see behind me is the model of this incredibly complex system, which was captured within a period of time. And that's great. The ability to capture that and in essence be able to rerun all of those unique scenarios is I guess, stage one. But actually we need to think about how we make this more sophisticated. So what we do is we look at the multi-transactional data, and then we look at what we refer to as feature clustering. So we know there's certain features that the application, every application website offers, even Keysight.com. One of those is order. And once we're able to understand the flows or the components that make up order, we can then look at those behaviors and cluster them together. Equally, we can see other potential flows, such as repeat order, that we can also see, which are a deviation off that main flow. So once we've able to do the feature clustering, we're able to identify every single transaction that ran against the system and work out the behaviors from each one of those systems, then we can actually create the necessary test cases. So in this case, you can see a whole stack of user journeys or test scenarios, depending on your terminology, that actually represent flows through the actual application. And as we can see with the repeat order one, we're going around in a loop, because once we've gone through the checkout process, we go and buy something else and then repeat. So this flow of being able to identify and feature clustering, what's the importance of this? And of course, that first big, large explosion of use cases, what really differentiates between this and something that's actually more manageable, and actually you can then start pulling together as features or functionality within your application? So here's an example of what was actually generated from that model. And what you see with the red lines within our Eggplant digital automation intelligence platform is you can see all of the interactions that are going between the different systems. And of course, we can overlay that with data. So, different data, different flows, and we can then rerun that to kind of give us an idea of what it was originally in the hyper baseline state, and then rerun that as automation. So this is a great way of being able to go from the left-hand side to the right-hand side and pull all that information back. So what we're really achieving by this is creating a level of model abstraction. So within the model abstraction, you've got this ability to kind of go from what humans would do. And of course, this is the kind of conversation which we have around model-based testing principles, which dates back all the way to Richard Bender and Dick Bender, which is, and his life's work. Part of it is humans model systems different to machines do. So we would maybe break it down by functionality. It might be logical user screens, but we might advance that and make more hybrid keyword driven kind of, okay, we understand how derivatives work. We know how FX works. So how do we understand the individual flows? And then we'll cluster those together, the main kind of FX engine and the main kind of capabilities it does. So we move from this standard model of all interactions and all systems to more reusable components, and then cluster those together. So this ability to start bringing that in with a certain level of sophistication is really a game changer when it comes to being able to take this technology and actually drive this to actually add some real value within your organization. So, you might be saying, well, how do we get to that point? Well, you can easily start with this kind of approach of being able to take everything you're doing manually. So if you've got UAT, BAT, you might have automated tests running Selenium, you might have exploratory testing, you might have crowd testers. You get them all to run it against the system. Once we've hyper baselined that environment, we can literally rerun the exact same transactions a day later. So great, that's giving you the ability to kind of have an entire digitalized digital twin of the system, which is continuously evolving as your system evolves. But what's the next step after that? Well, once you've rerun those and you've rediscovered those same flows, even if they're, and you've matched them against the original transactions, this really gives you the ability, let's say if you were doing a cloud migration, you hyper baseline the current state, and then you move to the cloud and rerun everything. Is it exactly the same? Is everything working as expected? If so, that's great. But typically what we find is certain parts will work differently. So you can see here on the timer, capturing it on September the 26th, rerunning it on 27th, and now we're seeing violations of our non-functional requirements. Maybe that's performance engineering aspect where you're kind of saying, well, actually 7 seconds to load the welcome screen exceeds the 3.4 seconds kind of tolerance level. Actually, we need to do something about that. So it gives you that ability to actually be flexible, to understand what the current state is, and then potentially what that future state is. And then, and really kind of start adding value from a functional and non-functional perspective. And I'm actually, while I'm here at QCOM this year, I'm actually meeting up with Scott Moore, who we've done a number of video casts and vlogs around digital twins, but also around effective performance engineering. So definitely check that out if you're interested in the effective performance engineering aspects of this. And actually, it's Sean Evans' birthday today, who's created a tool called GameDriver.io. I noticed on Facebook, so I just wanted to make a bit of an announcement and say happy birthday to him if he's watching. But he also wrote a book, EffectivePerformanceEngineering.com, with my friend Todd DiCaprio, which is a free O'Reilly's book if you go onto the website, which has some fantastic metrics. So we're talking about metrics, we're talking about maybe how do we move to this next level of quality engineering. Well, okay, so quality engineering is all about unlocking the capabilities that we're observing systems on the right-hand side, understanding how our changing these processes for the quality engineering standards, and then leveraging things like site reliability testing, site reliability engineering, chaos engineering. Actually, our good friends at Gremlin are here, and I did a great podcast on the QAlead.com with Colton, who's the founder, who actually was the guy who put together chaos engineering for Netflix and Amazon. And we're going to also try and get a great live stream with him while we're here. So this QA ops, this new way of looking at cognitive quality engineering, is really how do we build and change the behavior within your organization. And actually this morning, as I'm driving over to the venue, I was speaking to my good friend, Paul Gerard, and Paul, we're talking about cascading KPIs, about measurements around quality and test measurements and what that looks like from maybe an ISO 29119 perspective versus maybe a TMMI level. So what we're really trying to do here, what we're trying to drive, and we're incredibly passionate about at Keysight.com, is around how do we get to this point where, yes, every device like this iPhone Pro Max 14 has a CE standard on it, this Ultra Watch does. It, in theory, shouldn't explode when you're on a plane unless you've got a Samsung Node. But, how do we go from understanding the quality, a very subjective component, to say it's met all the quality certifications? How do we apply that to testing? And when I look around in front of me, and I see Intel and Cisco and AWS and everybody else, is how do I know what they've changed? When they do a new version of WebEx? Do I know it's better than the version before? Is it more stable? So knowing that it's a certain level, that will make a real difference when you're talking about applying this to maybe a secure government environment, maybe a healthcare, maybe a critical infrastructure. Maybe they don't want to take the latest SaaS version because it's not as stable as the previous version. So lots of interesting stuff that we're trying to do about shifting up quality, about bringing the conversation higher up. And then finally, this move towards predictive analytics. And again, that was my conversation this morning with Paul Gerard was, well, what metrics should you be checking or at least understanding? And that might be things like test coverage, right? That might be test data coverage. That might be understanding, bugs or, some other metric that's important to your organization and a way that you measure quality. Now, hopefully that process isn't being done by Excel. That's probably, you've sophisticatedly pulling that from different systems. So, how do we get to that point where we're able to understand and get information from the system? And then I kind of mentioned, like, I'd finish on a kind of a teaser, but also kind of mention around what we're doing from a quantum computing perspective. What we're looking at the moment as part of the project ADA and automation test assurance, which is like APM vendors in essence, is how do we bring all this information in, all this time series data from the tick stack or InfluxDB? How do we bring in things like multi-dimensional data that we mentioned? So that could be from things like your open telemetry, but also how do we bring that information? What might be knowledge graphs, right? It might be Neo4j, it might be some other GraphQLing kind of base, or even something like Azure Databricks and Spark ML. How do we standardize on bringing all of this exhaust data so that we can actually create and measure that system? And then once we've measured that system, how do we then understand and actually do some predictive ALM against it, do some quantum computing against it to actually give us that kind of insight about what we're doing and how we're actually testing it? So anyway, with that said, I've got 1 minute left before I close off today. Obviously, I'd like to thank everyone who's dialed in today to watch the TestCon event. Keysight are incredibly proud to be able to sponsor this event this year. And we hope that we've been able to kind of give you a glimpse into the future. And of course, I'm here tomorrow on the discussion panel around the future of automation with my good friend, Iran, who I've written, I think, 3 books with. And we did a book last year on digital quality. So, I'm really looking forward to taking some of your questions tomorrow. And of course, if you've got any questions you'd like to ask me before then, you can quite easily connect with me on linkedin.com/in automation. So easiest username of all. So with that, many thanks to TestCom team and the attendees who are watching today.
Thank you so much, Jonathan. We don't have any questions. I think we're a little bit overwhelmed. That was not only the future of testing and quality engineering, we're already into the future. Today we talked a lot about models and data and quality, high quality engineering. I'm more than impressed. We have wonderful speakers, and you are the crown jewel. Thank you so much. Enjoy the KubeCon with little envy.
I will do. Thank you so much, and I will see everyone tomorrow for the live Q&A.
Thank you. Thank
Bye.
you, everyone. See you tomorrow morning. We end the Quality Gems session for today, and I'll see you tomorrow. Bye.